Hey guys, thanks for joining me today in class, kind of class-ish. Today we're going to be talking about literal equations. So it's just kind of be an introduction. On Wednesday when we come back to class, we are going to do a lot more practice with it. So I just want to let you guys know that so that you can kind of see what we're talking about to begin with, and we'll go from there. So literal equations are equations that are often just written in terms of variables in which you are going to be solving for a variable. So this is something similar we do when we take an equation in standard form and we change it into slope-intercept form, right? We isolate the variable. So that's what we're going to start with here. If at any point as you want to pause the video, give a problem a try, and then watch the explanation after, please do so. I would like you guys to try ahead of time and see what you feel comfortable with. Again, if you have questions, make sure you circle them and we can address them in class on Wednesday. So here, right, if we're going to solve for y, the first thing we're going to do is we're going to subtract 3x from both sides. Okay? That leaves us with the 2y equals negative 3x plus 8. Divide both sides by 2, remembering to divide both pieces in the sum by 2. And we're left with y equals negative 3 halves x plus 4. Okay? That's how you get an equation from standard form to slope-intercept form. You have been solving literal equations for a long time. We're just going to look at some examples that are a little bit more complicated. Some are easy, some are a little bit more challenging. So here we need to solve for r. Well, d equals r times t. Well, instead of multiplying r by a number right now, it's multiplied by a variable. Okay, this you'll notice is a distance formula. Well, what we can do is we can go ahead and divide both sides of the equation by t, and we're left with an equation that's r is equal to d over t, as long as t is not 0, that is. Right, t cannot be equal to 0. Now, solve for big B. Well, area is equal to 1/2 of the sum of the two bases times the height. Well, right now that B is trapped inside the parentheses, so if we want to isolate it, the first thing we have to do is get rid of those parentheses. I'm going to rearrange how I write this expression because I think it's easier to see if I write it as 1/2 times the height, okay, times B plus little b. Okay. The first thing I would do in this problem is I would get rid of that 1/2. And the way I would get rid of that 1/2 is multiplying both sides of the equation by 2. So now I'm left with 2a equals h times, okay, b plus little b. I can go ahead and distribute, okay, the h. So I have 2a equals b times h plus little b times h. Okay. Subtract the bh, we get 2a minus bh is equal to big B times h. Okay. And then the last step I need to do is divide both sides by h, which leaves me with b is equal to 2a minus little b times h over h. Okay. What you are going to notice is I didn't divide by the h right away. And the reason I didn't divide by the h right away was because it was a variable. And I want my answer in terms of one fraction. Okay, so if we wanted, we could write our answer as 2a over h minus b, but I would rather have it written as this one fraction, which is why I didn't divide by h right away. Now we need to solve for h. Okay? So what we notice is that h is outside the parentheses. If we want to solve for h, we are going to have to isolate. And the first way we isolate this variable is we undo, okay, this addition, which means we need to subtract the LW from both sides, just as if it was a 2x, just as if it was a 10x, just as if it was a 5x squared. Right? We would subtract to isolate the h. So we have S minus LW is equal to H times L plus W. Again, remember multiplication is commutative, so if I write L plus W times H or H times L plus W, they are the same statement. Well, now right here I have H times this entire quantity. So I can divide both sides by that entire quantity and have an equation in terms of H. So if H equals S minus LW, divided by L plus W. And that is my final answer, right? I divide by L plus W, my H is isolated. I've solved for H. Again, okay, solve for B. Well, we have 5a is equal to negative 2b plus 10. The first thing we're going to do is subtract that 10 so we can isolate this negative 2b. So we have 5a minus 10 is equal to negative 2b. Now we need to divide by the negative. Okay? So what we're going to do is we're going to divide both sides by negative 2. This will leave us with 5a minus 10 over negative 2 equals b. But your answer with a denominator of negative 2 is not acceptable. Okay, so remember, all we need to do is stick that negative out in front. So b is equal to a negative 5a minus 10 over 2. Okay. You do need to put that negative out in front for it to be a proper solution. And I don't want any negatives hanging out or living in the denominator. Okay. We don't like them there. They don't want to be there. Let's get them out and in front of your expression. Okay. Solve for g. Well, now you've noticed that g is stuck in the numerator of a fraction. So you guys can go ahead and try this problem if you'd like. Okay. So since g is stuck in the numerator, okay, the first thing we need to do is deal with that denominator. Okay? How do we undo dividing by 2? Well, we multiply both sides by 2. So multiplying both sides of the equation by 2, we have 2s is equal to g squared. Okay? And now, well, we have g times t squared, so all we need to do is divide, okay, by t squared. And we know that t is not equal to 0. Because otherwise it's an undefined fraction. I would like you to write that variable we're solving for on the left, g equals ts over t squared, 2s over t squared. Okay. Now we're working on a little bit different. So to solve for w, well, what you should notice is that there are two terms with w in it. So just as our goal before was to isolate the variable we're solving for, we're going to do the same thing here. We're going to isolate the terms with w. So the first way to do that is subtract the LH from both sides. So we have S minus LH equals LW plus HW. Well, in order to solve for W, we need to rewrite this term on the right-hand side, so that there's just one W, which means we're going to have to change this sum to a product, which you guys should recognize is factoring. So what we're going to do is we're going to see that W is a common factor, and we are going to factor the right side of our equation to rewrite it as W times L plus H. And now I have W times a sum, that whole sum, so I can divide that whole sum from both sides, gives me S minus LH over L plus H. And that is our final answer. Don't get up trying to cancel out those H's because that will not work. You have a sum in your denominator. Okay? Don't do something you can't do. Okay? That does not work. And so your final answer is S minus LH over L plus H. Okay? This is the last one. You guys can go ahead and try if you'd like. Okay. So what we're going to do is we're going to solve for y. So again, notice that there's two terms in terms of y. So what you need to do is isolate those two terms. That requires us adding 8 to both sides. So b plus 8 equals xy plus 2yz. Okay? That y is in both terms. Okay? We want to rewrite that sum as a product, which means we need to factor out the y. So we have b plus 8 equals y times x plus 2z. And we can go ahead, divide by the x plus 2z. We get b plus 8 over x plus 2z equals y. We should write it from left to right. So y equals b plus 8 over x plus 2z. If you have any questions, make sure you ask in class on Wednesday. Have a great night.